David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower to suit your desire. Second, you can pause the video at any point to jot down questions or catch up with your notes. Third, you can turn on the captions so you can read my words on the screen. Today's video covers the area formula for a triangle using sine. So this is a way to get the area of a triangle without needing an interior height to do that. We have our standard formula, which is 1/2 base times height, but in a triangle like this, your height is not one of your sides. So you have to do additional calculations to find a height to find the area. Fortunately for us, we can just use sine and 2 sides and we can find the area of a triangle. So I've labeled my triangle just like we do for the sine rule and the cosine rule, where I have my angles are denoted by my uppercase letters A, B, and C, and my side lengths are denoted by the smaller letters, the lowercase letters, and the little a is opposite the big A, little b opposite big B, etc. So the area formula is pretty simple, and it's actually similar to the standard area formula for a triangle. It's 1/2 AB sine C. Now let's take a look at that picture. It's 1/2 AB sine C. So it's 2 sides and the included angle, sine of the included angle. That gives us the area. So in that case, there's 2 other ways to write this formula for the area of this triangle. So go ahead and pause the video and write those 2 ways. Let's see how you did. So we can also write 1/2 BC sine A, because that's this side times the sine of the angle between them, which is A. And we can also write 1/2 AC times sine B, which is 1/2 A times C times the sine of that included angle, which is B. Okay, find the area of that triangle. Using this formula here, go ahead and do your plug-in step and take that all the way through to the end, then come back. All right, let's see how you did. When I do that calculation, I get 56.7 units. So if you can't get that, stop the video, give that another shot. All right, now let's do that in the reverse direction. I'm giving you the area, and I'm asking you to find one of the sides. So same formula, but it's just a little different in terms of the math. So go ahead, pause the video, do the plug-in step, and actually take that through to the end if you think you can get there. All right, let's see how you did. I got 43.0, and here's how we did that. Is we have our x over here, so we have to divide through by all these 3 other things that x is multiplied by, which is 1/2 62 and sine 110. So they wound up on this side underneath the 1252. Then I just got out my calculator, did the calculation, and I got 43.0. Okay, here's another one. This time, we're gonna find the angle. So check it out. Here's my triangle. I have my angle marked theta here. That's an unknown at the moment. And I have a side of 6.5 centimeters and one of 4.7 centimeters. Now we're given the area. If the area is 7.64 square centimeters, find theta. So go ahead, pause the video, do your plug-in step, and solve for theta. Okay, let's see how you did. So what I did is I just divided through by 1/2, 6.5, and 4.7 to get sine theta alone. And that gives me this step. Here's my 7.64 divided through by those 3 quantities. Now that I have sine theta alone, I have to take the inverse sine of this side of the equation to find theta. And when I plug that into my calculator, I get 30.0 degrees. All right, let's do a slightly more complex problem. ABCD here is a parallelogram, boom, like that. You're given 2 sides and an angle and asked to find the area. This is a fairly straightforward calculation. You just have to understand something about a parallelogram. So go ahead and pause the video and see how far you get. Okay, if you didn't pause the video and you just want to watch me do it, let me give you one more hint. Parallelograms have certain properties. Opposite sides are parallel. That doesn't help us so much. But opposite sides are also equal. So this side, BC, is 7.3, so is AD. And then if DC is 12.4, so is AB. So that starts to get us somewhere. Now there's a few other things about parallelograms that are good to know. Opposite angles are also equal. So if this angle is 39, then so is this angle. That's 39. So we can exploit that now. We know that this triangle with this diagonal inside the parallelogram, this triangle is the same as that triangle because this side is the same as that, this side is the same as that, and this angle is the same as that angle. So, see if you can think of a strategy for finding the area of the whole thing. Okay, your strategy is find the area of this, which is a straightforward application of the triangle area formula, and then multiply it by 2, and that will give you the area of the parallelogram. So if you haven't already done so, pause the video and calculate that area. Okay, let's see how you did. So this is kind of interesting because the area formula has a 1/2 in it, and then we're just multiplying the whole thing by 2 because there's 2 of these triangles that we're after. So I have 2 times 1/2, that just goes away. And then I have 12.4 times 7.3 times sine 39, which gives me 57.0 centimeters squared. All right, I think you're seeing the progression here, that the straightforward application of the formula is pretty straightforward, like it is, and you can find area, angles, and sides. But then you can get more complicated geometric problems where you have to draw on other knowledge of figures and such to be able to use the triangle area formula and perhaps a few other formulas, as we'll do in this one, to actually get where you're going. So check this one out. We have PQR. It's an isosceles triangle with PQ equal to RQ. Find the area. I am a fan of marking the things you know on your diagram. So first off, PQ equals RQ. Boom, boom. Those tick marks mean those two sides are equal. Now think about isosceles triangles. There's one more thing we can mark on here that will help. Okay, if you remember that angles opposite the equal sides are also equal, then you know that you can write 61 degrees there. Okay, so now we're working with all of our givens. So we need the area of this triangle. So to use the triangle area formula, we're missing something. We need one more side, right? We have this side, but we don't have either of the two equal sides. So we're going to need to do something to figure that out. And there's a couple intermediate steps we can get there, and then we can do the area formula and find this triangle's area. So if you're feeling bold, pause the video and take that calculation all the way through. I'm going to do it in several little steps and see how you do. Okay, first step, figure out angle Q. What is that? Angle Q is going to equal 180 minus 2 times 61. That's what's left. We have 61 and 61, so that's 122. 180 minus 122 is going to be 58 degrees. So that gives us Q. So what might you do next? We're at a position where we can find either one of those two equal sides. Go ahead and set something up and find the side. Okay, what I recognize is now I could use the sine rule to find one of those sides. So I targeted side PQ, and I wrote a sine rule equation that has that as the one variable. So I have 12 over sine 58. That's 12 over sine 58, side over opposite angle, equals the other side that I want, PQ over its opposite angle. So that's PQ over sine of 61. So there's my sine rule equation. I rearranged it to get PQ alone, crunched my numbers, and got 12.4 for PQ. Okay. Pause the video and find the area of this triangle. All right, let's see how you did on this one. My area is going to be 1/2 times one side times the other side times the sine of the angle in between them. Crunch those numbers, and I get 65.1 meters squared. Okay, one last problem. And this one, a little bit more complicated. I think you can get it though. So let's take a look. This is a regular octagon. Now, pardon my drawing. I think I've got a little stretched out in the vertical zone, but just pretend that it's a perfectly well-drawn octagon. So it's a regular octagon with 8 congruent interior triangles. So when you have a regular geometric figure and you start slicing it up, you get congruent interior figures. So what that means is that all these triangles are the same. Same dimensions, same area. Okay, remember that. Find the area of the octagon. Now, You could develop an area formula for a regular geometric figure, but we don't have that. In fact, all we've got right now is the area formula with sine. Now this thing is not a triangle, but I bet you're already realizing that if you can calculate the area of one of these triangles, you just multiply it by 8 to get the area of the octagon. And indeed, that's the way we're going to go. However, we only know that we have 1.2 meters on the outside. Now, of course, we know that all of these are 1.2 meters going around because that's a regular octagon. All the lengths are equal. So, how might we do this? We need some stuff to be able to figure out the area of one of these triangular slices of our octagon. So think about that for a minute. Okay, so there's a trick. This is prior knowledge. Action. We know that to go all the way around on the interior, it takes 360 degrees, okay? We also know that all of these interior angles are the same. They're equal. We also know that there's 8 of them. So we can use that information to figure out how much degrees are in one of them. So I'm going to label this theta, and theta is going to equal 360 over 8. Okay. So theta is 45 degrees. That's 360 divided by 8. So far, so good. Now, we need a little bit more information. Okay, so check it out. If these sides are equal length, because these are all congruent triangles, it's all a regular octagon, we know that these sides are equal. That means we also know that these two angles are equal. Now we can figure them out. If that's 45, then each angle is going to be found this way. 180 minus 45 over 2. Because 180 minus 45 is what's left for both of those. If they're equal, then you're just going to divide that amount by 2 to get the angle. Okay, so there's our triangle. Two angles of 67.5, one of 45, and one of 1.2. We need to find the area of this triangle so we can multiply it by 8 to find the area of our octagon. So we're still missing something. We need a side, but we can use the sine rule to find either one of these sides. So I'm just going to label this with x, and then we'll go ahead and we'll use the sine rule to find x. So go ahead and pause the video and do that. Okay, so here's my sine rule equation. I've got x over sine 67.5 equals 1.2 over sine 45. That's how we set up the sine rule. So indeed, there's my equation. I rearranged, I solved, and I got 1.57 meters for x. So that's this x. It's also that one. We don't need that one. We just need one of these. So now I want you to pause the video and calculate the area of this triangle. All right, here's my plug-in step. The area for this triangle is just 1/2 times the 1.57 that we found times this side, 1.2, times the sine of the included angle. That's all of this right there. I crunch those down. I get the area of this triangle is 0.87 meters squared. Okay, we're almost there. Pause the video and find the area of our regular octagon. Woohoo, we're there. Let's see if you got this. Remember, we just calculated this area. There's 8 of these. They're congruent. That means they have the same area. So this area, which is just the 1, times 8 gives us the area of the entire octagon. There we are. So you're going to see problems like this with regular figures. They're going to give you little bits and pieces of it. Remember, you're going to need to use the area formula. You might need to use the sine rule in the middle of that. You might need to use the cosine rule. You might even need to use some regular old SOHCAHTOA trigonometry to find a side or an angle. Now that you've watched the video, take a moment to jot down extra notes or jot down some questions for our next class. You can also re-watch portions of the video that you didn't get the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.